Welcome to the deep dive. Today we're taking a really fascinating look at computational thinking.
Right.
Our sources basically describe it as a machine, maybe an algorithm, a routine doing the kind of work we usually think of as, well, human thinking.
Exactly. It's quite a shift in perspective, isn't it? Moving algorithms beyond just calculation tools.
Yeah, seeing them as broader problem solvers.
And the sources we're using are, well, quite a mix. There's this book that really jumps between philosophical thoughts on AI, some very practical stuff on machine learning models, and even how we humans tick when making decisions.
You can really feel the author's own journey in there, like a deep personal dive into it.
Definitely.
And that's kind of what we want to do for you, our listener. We know you want to get these big ideas quickly, thoroughly, but without, feeling totally overwhelmed.
So the plan is to unpack these complex ideas, filter things down a bit, and really pull out the key insights from this diverse material.
Okay, let's get into it then. Where do we start with the core idea?
So computational thinking at its heart. The sources sort of break it down into two main types, learning-based and non-learning-based.
Okay. Learning based, that's like AI, deep learning, that kind of thing.
Pretty much, yeah. Algorithms that learn from data, think neural networks.
Yeah.
The non-learning side is more, let's say, traditional algorithms, step-by-step instructions designed for a very specific task, like sorting a list or something.
Gotcha. And that leads to a really big question the text asks. Why do computers even think?
Well, the main answer seems to be problem solving, even when they're doing something that looks creative, like making music or art.
It's still basically an algorithm aimed at a specific problem.
Fundamentally, yes, which, as the source points out, is kind of different from us humans, isn't it? Our
Yeah.
thinking can be driven by, well, all sorts of stuff. Creativity, sure,
Yeah.
but also anxiety, boredom, you name it.
Huh, yeah, definitely.
And this difference in, let's say, strengths and drivers brings us to Moravec's paradox. Heard of that?
I think so. That's the idea that computers are great at what we find hard, and vice versa.
Exactly. It's fascinating. They breeze through complex logic, heavy math, stuff that ties us in knots sometimes.
Right.
But then things that are totally easy for us, like just seeing what's in front of us or walking across a room,
That's hard for them.
can be surprisingly difficult, yeah. The text mentions Garry Kasparov's experience with chess computers.
Ah, yeah. Deep blue.
Right. It really highlights this difference and hints that maybe the real power isn't just computers alone, but humans and computers working together. Collaboration.
Okay, interesting. So, shifting to human intelligence then, the source brings up this idea that maybe having a massive memory isn't the be-all and end-all for us.
Yeah, it's a neat point. It even speculates that someone like Isaac Newton, clearly brilliant, might not have had, say, an amazing photographic memory or working memory.
Huh. So maybe endless information access, like computers have, isn't always purely a good thing for human thinking.
Well, it raises that question, doesn't it? How does being constantly bombarded with information like news feeds 24/7 affect our ability to think rationally?
Yeah, does it make it harder to focus, maybe?
Possibly. Contrast that with the computer just instantly accessing and integrating vast databases. It's a fundamentally different way of handling information.
And what about emotions? Does the source touch on that?
It does, briefly. It mentions a couple of things. One is incorporating a kind of randomness into algorithms, almost like a computer emotion, maybe?
Like a guess based on past data?
Sort of, yeah. Seeing emotions as perhaps quick guesses based on experience. And it also talks about situations where human-computer teams might actually benefit from not having human emotion clouding the judgment.
Okay, let's talk about the evolution of AI itself. The source highlights a specific time.
Yeah, it points to around 2012 as a real turning point for deep learning, when it suddenly surged back into prominence.
Compared to earlier interest in things like spiking neural networks.
Exactly. It makes the point that timing is often crucial in tech. Having the right data, the right computing power. It all has to kind of align for an idea to really take off.
Makes sense. And the source distinguishes between different types of AI.
Right. It talks about narrow AI versus general AI.
Narrow AI is what we mostly have now, right? Good at specific tasks.
Yes. Like image recognition or translation or playing Go. General AI, an AI that could perform pretty much any intellectual task a human can, that's still, well, mostly theoretical, or at least a long way off.
So given that, the text asks, do we really need AI?
And the argument presented is basically,
Yes.
at least for now, until we can perfectly model absolutely everything, AI's generality is incredibly useful.
Generality, meaning it can be applied broadly.
Yeah, The same underlying techniques can tackle wildly different problems. And this idea of transfer learning, where knowledge from one task helps with another unrelated task, that's a huge advantage.
So AI isn't just one thing, it's more like a versatile toolkit.
Precisely. And we're seeing it integrated everywhere. The source mentions data science, obviously, but also image segmentation.
Where deep learning helps figure out the important features automatically.
Exactly. It automates that feature engineering step, which used to be very laborious, and even in fields like quantum mechanics.
Wow, and everyday stuff too.
Oh, yeah. Things like noise cancellation software on your calls, Crisp, NVIDIA RTX voice, those often use AI principles. Computational thinking in action.
Okay, this connects to another interesting comparison in the source. Simple models versus complex ones.
Right. And what's kind of surprising is how effective very simple models like basic regression can be.
Sometimes even better than human experts.
Apparently so in certain situations. The text mentions work by Kahneman and others showing this. It feels wrong, doesn't it? We assume complex is always better.
Yeah, definitely.
But there are trade-offs. Simple models like linear regression are, well, simple and fast. Machine learning models are more adaptable. They learn from new data. The source gives some rules of thumb for when to pick which.
It uses a stock price example, right? Using simple ratios.
It does, showing that even basic financial multiples, ROE, PE, payout ratio, things like that, can give you some insight.
But with a warning label, I imagine.
Oh, absolutely. Don't just rely on those, especially if you're a new investor drowning in information anyway. It's just an illustration of the principle.
And there was another example, chemical distillation.
Yes. Comparing a simple linear regression model to predict chemical purity versus a simple neural network.
And the simple one held up.
Pretty much. The added complexity of the neural network didn't necessarily give a more accurate prediction in that case. It's a great reminder. Complexity isn't always the answer. Sometimes simple is genuinely better.
Okay, let's switch gears a bit. Bias in AI. That's a major concern.
A huge one. And the source tackles it directly with that really stark Google Translate example.
The one about cabelo feio, ugly hair, in Portuguese.
That's the one. Searching for that term predominantly showed images of black people's hair.
Wow.
Because the training data reflected existing societal biases in Brazil. The algorithm learned from human interactions, including our prejudices. It holds up a mirror, and sometimes it's not pretty.
So the AI isn't inherently biased, it learns the bias from us.
Essentially, yes. Which leads to another point the source makes about Google Translate being, in a way, shallow.
Even though it uses deep learning.
Right. Deep learning doesn't automatically mean deep understanding of language, nuance, context. Getting AI to truly grasp meaning, that's still a really, really hard problem.
And other limitations.
The text mentions spatiotemporal understanding, like knowing the difference between a static photo of a car and an actual car moving in real-time video. Recognizing the dynamic nature of the world is still tricky for AI.
Okay. What about the future? Where is this heading?
Well, the text brings up brain-inspired AI. It mentions Professor Kasapov's work.
Focusing on more symbiotic human-machine interaction.
Yeah, exploring that kind of collaboration. And it briefly touches on things like brain-computer interfaces, where AI plays a role.
But it also raises some flags, right? Ethical concerns?
Definitely. The potential risks are mentioned. Government surveillance using AI, threats to human rights. These aren't just sci-fi scenarios anymore. They're real considerations.
So bring it back to the practical side. Computational thinking isn't just AI, is it?
Not at all. The source emphasizes that a huge chunk of just regular coding is computational thinking, breaking problems down, figuring out steps.
And large language models like ChatGPT, how do they fit in?
The explanation is actually quite, well, simple at its core. They work by calculating probabilities, basically, figuring out the statistical likelihood of which word should come next, based on all the text they've been trained on.
Just predicting the next word.
Auto-regressively, yes. Word by word, based on what came immediately before. They don't really plan ahead in the way a human writer might.
And that temperature setting they have.
Yeah. That controls randomness. Turn the temperature up, you get more varied, sometimes unexpected output. It can look like creativity.
But it's not true creativity.
Well, the source makes that distinction. Generating diverse text based on probabilities isn't the same as a human having a novel insight or making a truly new connection. It's statistically interesting, perhaps, but not quite the same spark.
So wrapping things up then, what's the big takeaway here?
I think it's that computational thinking is this incredibly powerful and still evolving way of tackling problems. And AI is a major, rapidly growing set of tools within that framework.
Yeah, and I found it really insightful exploring these sources, like realizing how effective simple models can be sometimes, or how much timing matters for tech adoption. That bias example was quite sobering, too.
It really was.
So maybe a final thought for you, the listener. As computational thinking and AI weave themselves deeper into our lives, what's our responsibility, to understand what they can do, what they can't do, and grapple with those ethical questions that keep coming up?
That's a really good question to ponder. It definitely requires ongoing attention and critical thinking from all of us.